Gibbs energy and E naught cell. What is E naught cell? E naught cell is EMF of a cell. EMF of a cell, electrochemical cell I am talking about. So what is the relation? The relation is delta G equals to minus NFE cell, or delta G naught equals to minus NFE naught cell. So what is this naught? Naught is again for standard conditions. That means temperature is 298 Kelvin and pressure is 1 bar. So if you take these conditions, 298 Kelvin temperature and 1 bar pressure, then you will have these values, delta G naught equals to minus NFE naught. And if you have normal conditions, then we will be using delta G equals to minus NFE. Without this naught value, we are talking about normal conditions. If this is naught value is written at the top, that means standard conditions. All right. So now we need to understand that what is F. If we are talking about delta G equals to minus NFE, right? So what is F? F is 1 Faraday. How much charge does this means is 1 Faraday equals to 96500 coulomb of charge, right? One equivalent of charge. Similarly, what is this N about? This N is total number of electrons involved in the reaction, total electrons gained or lost during reaction. Total electrons gained or total electrons lost, or we can say total number of electrons exchanged during a reaction. That is the value of N. So for a reaction we will have N, we can put F equals to 96500. If we know delta G, we can calculate E naught. If we know delta G naught, we can calculate E naught. Same way, if we know E naught, we can calculate delta G naught, right? Then we move on to third law of thermodynamics. What does it talk about? Third law of thermodynamics is all about entropy change at absolute zero. So at absolute zero, perfectly crystalline substance will have total entropy equals to zero. At absolute zero, what is that temperature? Absolute zero temperature means 0 Kelvin. At 0 Kelvin, a perfectly crystalline substance will have a total entropy equals to 0. Right? So, what is the use of that? So, use of third law of thermodynamics is basically in calculating entropy values or entropy change during a process. Alright, we have discussed it over here that if you have a formula ds equals to Cp by d, Cp into d by dt by t. So what did this mean? You can say that ds means entropy at T temperature minus entropy at 0 Kelvin temperature. So we will take this value as 0. So you can easily calculate entropy at T temperature. So absolute values of entropy could be calculated using third law of thermodynamics. Alright. Now we have couple of more formulas that those say that entropy of a reaction could be calculated from total entropy of all products minus total entropy of all reactants. Total entropy of all products minus total entropy of all reactants will give you entropy change of a reaction. Alright. So that is it. I'll give you a small trick. If in a reaction, in going from reactant towards product, if number of gaseous moles is increasing, that means entropy is increasing. Did you get that? I hope you did. I told if in going from reactant towards product, total number of gaseous moles in product side is more than in reactant side, that means entropy is increasing. And if total number of gaseous products is less than gaseous reactant, that means entropy is decreasing. For example, I will show it to you. N2 plus 3H2 gives you 2NH3. That means number of gaseous products here is 2 and number of gaseous reactants is 1 plus 3. That means on reactant side we have 4 moles of gaseous reactants, whereas in product side we have 2. That means 4 to 2 we are going. That means number of gaseous products is decreasing. If gaseous from reactant towards product, if we go in this reaction, number of gaseous product molecules is decreasing. So more the gaseous molecules, more will be entropy. So number is decreasing for gaseous substances, so entropy is decreasing in this reaction. Right? Simple trick. Similarly, if we have this reaction, let's say PCl5, if we have this reaction, PCl5 decomposes to give you PCl3 plus Cl2. So gaseous reactant is 1, but gaseous products are 2. Right? So we are going from 1 to 2. So number of gaseous substances is increasing in going from reactant towards product. That means entropy is increasing in this reaction. So if product side gaseous moles are more, entropy is increasing. If product side gaseous moles are less, then entropy is decreasing. So this is the easiest trick I told you to understand in a reaction whether entropy is increasing in a particular reaction or entropy is decreasing. So in this reaction entropy is increasing because you have one gaseous mole here, you have 1 plus 1 2 moles here. So number of gaseous moles increases, so entropy do increases. That is what we have for now.